Thanks very much. Welcome everyone to this webinar on gender and green and sustainable chemistry, part 4 of our series on gender equality and future chemicals management. Happy to see so many of you here. My name is Minu Hemati and I'll be facilitating the session. Allow me to introduce our host. MSP Institute is a small charitable association based in Berlin, Germany, dedicated to supporting high quality dialogue and collaboration among stakeholders, stakeholder participation, and good governance. We've been working on gender and chemicals since 2017 with support from the German Federal Environment Ministry and have been active in the SAICM process since then. I'm a co-founder and an associate advising the Gender and Chemicals project. Anna Holthaus is the coordinating our work on gender and chemicals, and Pia Zimanda, who you also see here today, is our intern, and Anna and Pia will be co-facilitating and watching the chat of this webinar for us. So if we go to the next slide, welcome to our 4th webinar in a series. We invite you to join us once a month for 45 minutes on gender equality and its interconnections to the world of chemicals. These webinars are opportunities to learn from experts, policymakers, and practitioners, and to discuss how we can create a gender-responsive future framework for the sound management of chemicals and waste. The recordings of webinars 1, 2, and 5 can be found online at our homepage. Webinar 3 is recorded with a slideshow, and webinar 4 comes after 5 because we had to move it. In any case, today is number 4 on green and sustainable chemistry, and the last one of this series for this year is on the 22nd of December on gender and SAICM beyond 2020 with Brenda Kuckuck from the SAICM Secretariat and Giulia Carlini from SEAL. We'll probably continue our series next year. There's a number of people and topics lined up, but we also love to hear from you. So let us know if you're interested in giving a presentation on gender and chemicals related issues. Please also note that we're recording this session and we'll make it available on our website and the YouTube channel. If we go to the next slide, we see the agenda of today is pretty simple. We will have a presentation on sustainable chemistry by Professor Kümmerer and a statement on sustainable chemistry from a gender perspective by Hans-Christian Stolzenberg and Regina Schreiber from the German Federal Environment Agency. And we will hear those two presentations, 15 minutes and 10 minutes respectively, and then open for questions and comments. We will use the chat function, but you can also raise your virtual hand. You probably all know at the bottom of your Zoom window, you find an icon for participants and an icon for chat, and you click on those to open those functions on the right-hand side of your Zoom window. If you have a technical problem, please use the chat. We'll try and help. If your connection isn't good, try switching off your video, but if you can, keep it on and we can see each other a little bit as a community here. Thank you so much. But now let's dive into the topic of green and sustainable chemistry, and allow me to introduce our first speaker, Professor Dr. Klaus Kümmerer. He's Professor of Sustainable Chemistry and Material Resources and Director of the Institute of Sustainable and Environmental Chemistry at the public Leuphana University in Lüneburg, Germany, as well as Director of the Research and Education Hub at the International Sustainable Chemistry Collaborative Center, ISC3. He's founding and chief editor of the scientific peer-reviewed journals Sustainable Chemistry and Pharmacy, as well as Current Opinion in Sustainable Chemistry. Klaus Kümmerer serves on many national and international committees and chairs the International Green and Sustainable Chemistry Conference, as well as the annual Summer School on Sustainable Chemistry of the ISC3. We're very happy that you can join us today, Professor Kümmerer, and you will give us an overview introduction on sustainable chemistry. Professor Kümmerer, you have the floor. If you would like to share your screen.
Yeah, thank you, Ms. Hemati, for the kind introduction. And I'll try to share the screen. Yes, let me see. And also for inviting me and giving the opportunity to present our understanding. That means Leuphana's and ISC3's understanding of sustainable chemistry. Yeah, we have a process ongoing which is called Common Understanding. I think that is also of interest for SAICM. And I think ISC3 is well known, so I will not spend any words on this. Yeah. Oops. It's always a challenge. Yeah. So just for setting the scene, you may know that there are around 350,000 chemicals and mixtures of chemicals globally marketed. And we talk of chemicals, but very often they are more complex products. Some of them you see in these slides. So if we talk about chemistry, we have also to clarify what we are talking. We are about science? Are we talking about human value propositions and frameworks, or the chemical sector or the chemical industry? And as you know, 150 years of chemistry, if we refer to the beginnings of it, the periodic table, but also chemical industries, a huge success story, because everything around us in our modern life is chemistry products, or based on chemistry products, chemistry inventions. But you probably all know that also about 30,000 chemicals are environmentally relevant, for example, not included the products of incomplete degradation in the environment or effluent treatment. That in Europe still about 62% of chemicals volume used is hazardous to humans. About 1.6 million deaths are estimated that can be attributed to chemicals, many more to chronic diseases. One example you see below here, neurological behavioral. So we are moving also from acute intoxication to more long-term chronic issues. And if we would now analyze our blood, then probably in the end we will come up with several hundred synthetic chemicals present in our blood. So that's just, let's say, setting the scene. So you probably know there's green chemistry, and interestingly, there's different understanding of it. Green chemistry, you see the principles here, is well known, and in fact, it has a focus on synthesis and properties of chemicals. So it's green synthesis and green products, which is in view there. And I'd like to have a closer look there to make you understandable why that's not enough, why we need also sustainable chemistry. And just to say it already here, green chemistry and sustainable chemistry is not the same. It's not synonyms, it's different. So green chemistry asks for using renewable resources. The very first questions, metals are not renewable. What about them and how to deal with them? Another, let's use CO2 as a resource for nearly everything. But from a chemical point of view, you should be aware that it's not by chance that CO2 is a product of each combustion and incineration, because it's a very stable molecule. That means it has low energy content. And if I want to use it for whatever it is, I first have to bring in this huge amount of energy. Yes, I can save a little bit if I use catalysis, but that does not change the whole situation. And then you can say, yes, let's use renewable energies, but there's a lot of competition for renewable energies. Think just about mobility, the digitization, etc., etc. And we need materials, for example, metals, but also others. So, and these things are not really addressed by green chemistry. And also, if you have a look on the right side, it's more like an impetus, prevent. Yeah, it's you should do. And also, we do not and you can go through them, most of them. Yeah, it's a mixture on just a topic, benign by design. It's not designed for, but sometimes it's designed for. So for me, it's still a little bit after this 25 years, a sort of crude collection of different approaches. Important, but maybe we have to better understand. And I would say we should call it chemistry for greener synthesis, because chemistry itself cannot be green. And even if it could be, we do not know what is green. We can only compare. Therefore, we also use metrics. And that makes a big difference to science. Science is a non-normative approach. So chemicals or molecules do what they should do under conditions given, or what they do. And we cannot say that's good or bad. If we say greener is better, then that's a human value proposition. So in contrast to science, the application of the science, chemistry, wherever it is and how it is, it's a human value proposition. And I think that's important to know, because nature does not tell us what's better or greener. It's just as it is for nature. And a few other aspects. Green chemistry does not address the total substance and material flows and ever increasing use of nowadays the complete periodic table, coming up with more and more different chemicals. So increasing chemodiversity, as I call it. So we have to deal with more and more entities, also some which we think could help us in terms of greenness or maybe in sustainability. But later on, at the end of the life, we all have to cope with these different entities, molecules, materials, products, etc. And we see this also in products. For example, here you see a soccer tricot from Uruguay, I think it is. And you see, even in this, we have different polymers. It's not just cotton. And if you have a look into the chemicals list for manufacturing and textiles, and starts from the pesticides you use, but also in the companies, the spinning, etc., and the weaving, then there are about 600 different chemicals mentioned. They're just to produce it. Yeah, and we have the dyes, etc., etc. Another example, plastics. We say plastics, but in fact it's polymers. Yeah, a long chain of molecules, and it could be homopolymers, but even on this molecular level, we have an increasing complexity. And then, as you see in the middle, it's not just the polymer itself, consisting of different functionalities and atoms. We also have fillers, plasticizers, so-called additives, which we have to care for. If we want to go for recycling, we have to understand. And we see that nowadays, everything is, plastics is everywhere, so we can talk about, we can name it plasticization of this world. So what we have on the media with microplastics and the bags, it's only part of it. If you think of buildings, ISCC just finished a nice study on this. A lot of plastics is also in buildings involved. And there it is for the next 20, 30, 50 years. And it's, again, it's not just a polymer and different polymers, it's a complex product. That's the increasing success story is also reflected in the use of resources. As you can see here, everything is increasing. Again, not addressed by green chemistry. Green chemistry is not interested in this. And then we have circular economy. Just one remark, there is no endless recycling. It comes with a cost, it comes with another waste, it comes with energy needs, and there is no upcycling. If I increase the quality of a product somewhere or in some respect, then I have to pay a price in terms of waste, in terms of energy, in terms of losing, in terms of downgrading other materials then. And also we have to be aware, we cannot circulate everything. Just think about the ingredients of your shampoo, maybe as one example. Yeah. So also limitations here. And we also have to be aware that there is a huge disconnection between environmental, social, economical effects and ethical issues. They do not happen at the place nowadays where synthesis or production or application of products is going on, or where the return of investment is. All these things we have to include for our understanding. So what we need is a broader thinking, and some colleagues already started years ago to call this systems thinking, to take into consideration not just the products or the synthesis, but also their application and even the wider context they are used, why they are used. And that if you have this broader context, then you can come already see doing better without less chemicals, not just substituting with less hazardous as green chemistry does, but you can go even further, doing without. For example, silicones in conditioners. Years ago, everybody had said in industry, that's not possible. Nowadays, you can enter a shop, a drugstore in Germany, for example, shelf over shelf advertising without silicones. Also in food, no artificial or no synthetic flavors and colorants. So it's possible without. And for our understanding, that's also part of chemistry, because it has to do with the application of chemical products. And part of application is thinking about, where do I really need them? And here, just another example from pharmaceuticals, antibiotics use patterns. It's a standardized data here, daily defined dose per 1,000 people. And you see the Netherlands only about 1/3 than in Greece. I could show you many others. It's always different countries, the best and the worst. So that tells us here a factor of 2 we can save, and the same holds for others too. So conventional chemistry versus sustainable chemistry. Also, the old model is on tonnage, product for value creation. The new model is on service. Service and functionality are important. And sometimes you need a chemical. And if you need a chemical, then go for green chemistry, but do not just fulfill one, but fulfill as many principles as you can. Nowadays, we have a flooding of new products and synthesis and processes. I see it with the publications we receive, the manuscripts with the journals. Everybody says that's green, but nobody asks or gives details. Why is it green or greener, to be correct? So we need a much broader framework that goes beyond chemistry for circular economy. We need sustainable chemistry or chemistry for sustainability. And the main important point here is it starts and asks first, what is the service and function I want to have? And I give you just a few examples, and then first try to do without. And if not, then go for a chemical according to circular economy on including the principles of green chemistry. And stakeholders have to be included in ethics. For example, some of the metals, they are mined in areas where we have civil war or child work, not addressed if we have this more narrow view of green and circular economy and chemistry in there. Okay, I just wanted to keep it short, so that's it already, but I can give you some examples. One example for using less is if you go to a hospital, is it about using as much disinfectant as possible, or is it to keep up a good standard of hygiene? I think it's clear it's the latter one, but if you have this view, then you see already training is important. Or if you build a new hospital, think about how to design the rooms or the walls and the floors to use less disinfectant, to do without disinfectants. So, and therefore sustainable chemistry and chemistry for sustainability is inter and transdisciplinary in its understanding. Yeah, and that means chemists have to talk to other professions, but other professions have also to listen to chemists. And also design of systems is very important. It's design of chemicals also, yeah, for circularity, for greenness, but also the whole system. Yeah, that's also important. So that's in a very brief, in a nutshell. You asked me to do was challenging, but it's important that we are aware that on the one hand, green chemistry or chemistry for greener products, chemistry for circular economy, and chemistry for sustainability are human value propositions in contrast to science. And this thinking opens up very much that we have many more opportunities to make chemistry as a sector and application of chemicals and chemical products to contribute in a real sustainable manner to sustainability. Only then it's sustainable chemistry. Thank you.
Thank you very much, Professor Kümmerer, for giving us that overview. It also made me understand at the very end why you're so active in education and educational programs. This is obviously needed, and I have a number of questions at the back of my mind. But we'll get to the statement on sustainable chemistry from a gender perspective first, and I'd like to introduce our two speakers. But before I do that, I'd like to check if Regina Schreiber is actually here, because she had trouble joining. And Regina, if you are here, could you just make a sound? I think she's here by phone, but we're not absolutely sure. So if you can say something, there's two people here via phone, and I'm just going to unmute one of you. So
It's
we're not
obviously
quite.
one from Germany, and if then
Hello? Can you hear me?
Yes, we can hear you. Welcome.
Oh.
That's
Oh,
a very good sign. Thank you very
Finally.
much.
Okay.
Thank you. You keep your settings as they are. Don't move anything, and we'll call on you in a minute. Thank you very much.
Thank you.
Thanks. So I'd like to introduce our two speakers who are going to join forces to present a statement on sustainable chemistry from a gender perspective, both from the German Environment Agency. The first speaker is Dr. Hans Christian Stolzenberg. He holds a master's degree in biology from the Institute of Microbiology in Braunschweig and wrote his dissertation in Berlin on the influence of pollutants on luminescent algae. Since 1997, he's been working for the Department of Chemical Safety at the Federal Environment Agency, where he became head of the International Chemicals Management Department in 2012. In addition, Hans Christian is also the German national focal point for SAICM and the Minamata and Stockholm Conventions. And Regina Schreiber, who will be our second speaker from the Environment Agency, she's been appointed Gender Equality Officer at the German Environment Agency in September this year. She holds a master's degree in chemistry and has been working on environmental risk assessments of pesticides, international chemicals management, and the Stockholm Convention before. The Gender Equality Office at the German Environment Agency also includes a scientific advisor who's responsible for gender mainstreaming at the agency. Together, Regina Schreiber and that colleague, Ansauer, and their team support all the agency's departments in identifying gender aspects of environmental matters and research. They also work on promoting the use of gender-neutral language at the agency and in all its publications. So with that, I hand over to Hans Christian Stolzenberg for your statement on sustainable chemistry from a gender perspective.
Thank you very much. Sorry, Anna?
Very sorry, but Bino, can you make me a co-host, please? And then I can show the presentation.
I am so sorry.
Oh, that would be fine.
That would be very good.
Thank
because Anna is managing the presentation for Hans Christian. Thanks very much for your patience, everyone. And here we go.
Great. Great, that works. And hello to all in all time zones. Someone has background noise. If you can please mute your mic. Thank you. Great. Yeah, and before I start with a statement, I would very much like to gratefully acknowledge the discussion with MSP colleagues and colleagues in our agency on that statement, which was very inspiring for me. Yeah. With the year 2020, the so-called decade of action to transform our world begins. And Anna, you can show the first slide, please. We have only one slide per speaker, and here you have the summary. Chemistry, if you think twice, or if you remember what Klaus Kümmerer just presented, is a thoroughly cross-cutting element of almost all human activities. Thus, it can or even has to play one of the key roles in the transformational process of our societies to the sustainable development. Therefore, we need a new way of systems thinking and a transformative approach to the world of chemistry with a broad understanding of what chemistry for sustainability means. In particular, we need to include the consumer and user perspectives, not only the producer's perspective, as this is predominantly the case with the green chemistry approach. The concept of sustainable chemistry, as we understand it, aims to include the perspective of societal demands and responsible consumption within the planetary boundaries. This creates a possibility to amend the conceptualization of chemistry as a science by including social aspects and various issues of justice, thus making sustainable chemistry a truly cross-cutting element of sustainable development. Sustainable chemistry needs to integrate ethic principles on the basis of human rights, including principles of non-discrimination and equal opportunities. So far, however, it seems we are only beginning to consider what sustainable chemistry could mean from a gender perspective. Therefore, I would like to brainstorm a little bit how a gender-just, green, and sustainable use of chemistry could look like. I would then like to discuss with you how gender justice could and should be included in the approaches of a green and sustainable chemistry for the sake of sustainable development. So let's imagine a sustainable and gender-just world of chemistry. In my view, gender-just sustainable chemistry would mean that 1, no gender inequalities are there. 2, all gender are agents of change and take leadership roles. And 3, all gender benefit from it. So let me say a bit more about these 3 points. At 1, no gender suffers from toxic chemicals, nor from structural inequalities in chemicals production, chemicals use, or chemicals policy. That means we have data and research on gendered health effects, and we are aware of exposition paths due to gender roles and the gendered division of labor. We use this knowledge to protect health and transform gender roles. We fight against gender inequalities in the whole life cycle of chemicals. That means in design, production, consumption, recycling, disposal. We protect all gender from becoming infertile, and we support those who are. And we correct policies related to chemicals that have an unfair impact due to gender. On the second point, all gender are seen as agents of change and take leadership roles. Women participate fully and equally in chemical policy making and policy implementation at all political levels. Women's specific experiences and expertise due to gender-specific distribution of labor and including the knowledge of indigenous women are fully and equally recognized. This can help revealing challenges previously unnoticed and developing alternative gender-just solutions. On the third point, all gender benefit equally from sustainable chemistry. Chemicals innovations both protect and benefit the lives of all gender. All genders' education, research careers, businesses, ideas, and products are supported equally. Women can earn as much money as men through sustainable chemistry approaches, and that means closing any gender pay gap. And having said this, I give further to Regina.
Thank you very much. I think I have to unmute you, Regina. And I'm trying to do that now.
Okay, now can you hear me?
Yeah, perfect.
Okay,
Thank
all right.
you.
Thank you very much,
Go ahead.
Christian. I take on from here. I don't know if you see the second slide, which we have prepared, but if not,
We do.
please put it on the screen. In addition to what we just heard, and with reference to a number of well-known principles and concepts, we can think of further elements for sustainable chemistry from a feminist perspective, including a feminist ecological economy perspective. First, there's the precautionary principle, which means organized through the feminization of reproductive labor, precautionary consumption exerts pressure on women to identify and purchase goods that are deemed non-toxic, natural, or organic in order to avoid toxic exposures. The second is the polluters pay principle. Women are less responsible for chemicals pollution as they hold fewer leading positions in chemical companies and industrial sectors, and they demonstrate more environmental awareness on average, while they usually suffer more from the indirect costs transferred to the taxpayers due to the before mentioned gender pay gap. Then the third is the circularity principle. One of the main demands towards the feminist ecological economics is the re-evaluation of the reproduction of nature and to consider how production and reproduction could be united. The fourth element is respecting planetary boundaries. Feminist ecological economics also question the growth paradigm because it undermines and devalues ecological processes and caring activities. The chemical sector might be one of the first sectors whose predicted growth rates will be questioned. Double production for chemicals by 2030 with partly uncontrollable consequences for people and nature will have to be debated and scrutinized concerning their impacts on planetary boundaries. Fifth is generational justice. Chemical pollution can be transferred to future generations, especially through the female body during pregnancy and breastfeeding. And the sixth element is the global North-South justice. The entanglement of structural gender equality with colonialism and racism leads to the fact that women from the global South and women with migration background in the global North are more exposed to chemicals. For instance, many women in the predominantly female cleaning business have a migration background. In sum, the question arises how gender justice could and should be included in the approaches of green and sustainable chemistry. Therefore, I would like to highlight possible principles for including social and economic sustainability in green and sustainable chemistry by drawing on the work of Lotte Asfeld. Asfeld is a Dutch scientist who is studying the societal aspects of biotechnological innovations with her research group. She proposes 3 additional elements for sustainable chemistry, while she proposes to add these to the 12 principles of green chemistry. We rather see them as valuable elements in the broader concept of sustainable chemistry. The first element she wants to add is ensure that the benefits associated with the chemical production process are distributed fairly and equitably throughout the entire value chain. The second is that wherever possible, the design of chemical production processes should take into account the values and interests of a wide range of stakeholders. And the third element is that products of green and sustainable chemistry should contribute to at least one of the Sustainable Development Goals of the United Nations. These 3 elements might be useful to initiate the dialogue on gender and green and sustainable chemistry, and I'm looking forward to hearing your thoughts and ideas now. Thank you very much.
Thank you very much. Thank you for giving that statement, Hans Christian and Regina, and thank you again to Klaus Kümmerer for his presentation. I'd like to especially thank Regina for doing this, although the technology didn't work as easily as she was hoping, and doing this over the phone is not easy. Thanks very much. I'd like to open for comments and questions from you all. Please don't be shy. You either raise your virtual hand using the, when you open the participant list, you can access that, or you use the chat to make a comment or ask a question. And that might take a second. We have that second. We have 10 more minutes, so please don't be shy. There's been quite a number of concepts and ideas and research results being put forward. Maybe not that easy to digest, but please feel free to ask whatever it is that you're most interested in. I might actually start with a question because people might take a minute. And it's a question, maybe one to Professor Kümmerer to start with. We've had all 3 of you mentioned the need for transdisciplinary work or for working across sectors. And when I hear this about chemistry and having to consider values, having to work with social scientists, maybe with lawyers, with economists, with others who you're not usually meeting in your lab. And with that being necessary to create sustainable chemistry, can you tell us a little bit about what works to do this? We all know it's a problem, and you have to unmute yourself. Yes.
It's a challenge in a positive sense, I would say. And first of all, that sounds a little bit contradictory, but you need a sound basis of your own discipline where you're starting. And then the next is you have to be open. You have to be aware that there's more outside. So as a chemist, as long as you're working only in the lab and you're interested in studying, let's say, theoretical things and synthesizing compounds to better understand the chemical bond, that's fine. But as soon as you go outside or you are aiming for a product, for a patent that could go outside, think about what could be the follow-up and what could be the impact and what's involved. So I think the most important thing is being open-minded and try to understand the other people from other disciplines. And there's no need that you are an expert for everything. I think that would be counterproductive. But you have to, that you understand, that you're open-minded, try to develop a common understanding, also a common language, and work together. And because if we think transdisciplinary and interdisciplinary is just about everything, you can do, how should I say, talk about everything and to be an expert in everything, that's not possible. And that will not be the future. But talk to each other, for example, if it's about building a house, talk to the architects and the investors and tell them, okay, these and these products or chemicals you should avoid. And then the architect can say, yes, you can, but then we need to construct a little bit different. For example, you should have a roof where the rain cannot have so much access to the outer wall, and then there is no need for preservation or specific chemistry on there. You can just use the natural material, and such things. Or if you think about what I mentioned with this example with a standard in a hospital, hygiene standard, then you talk to other people and say, hey, what is your workflow? Why do you need their disinfection? Or what could be a better construction on your workplace to be more on the safe side, etc. COVID-19 is a nice example, I would say. Yeah, just avoiding contact or reducing contact, I would say. And I'm not very fond of this term social isolation, because it's not real isolation. But that's much more helpful very often and works always compared to other measures like disinfecting. So there's no need to disinfect your household, for example. Other places are. That is, we need a specific understanding, and we have to develop together.
Thank you very much for those comments. I'm a psychologist by background, so I like it when you say, well, it depends on your open mind and your ability to communicate and collaborate, of course. I don't want to hold back Hans Christian and Regina to respond to anything or add anything, but there's a comment in the chat. And Ahmad from Iran, he says, in female agriculture workers, particularly in rice paddies, there are high exposures to pesticides, and it's mostly female workers. Now, if we look at that from a sustainable chemistry and from a gender perspective, what is it that comes to mind when we think about these agricultural workers, these women in the rice paddies?
Oh, okay, yeah. I just noticed in many years of work that I was in Mazandaran. At first, before University of Tehran, I was in the University of Mazandaran, and always watching and seeing these female workers. Sometimes some of them with the baby on back, and really high exposure.
Yes. So thank you very much for this question. It's an example, and I'm wondering if our speakers want to make a comment, or other participants would like to make a comment. What's the solution here? Would the solution be to have as many men working in those fields, to look at the pesticides that are being used, but the need to produce a high yield? How do we approach this particular example from a sustainability?
The female exposure to the pesticide and chemicals is also a big issue in wildlife. That I don't know that if we are allowed to talk about that or comment on that, or just, gender and chemicals is only about the human being. Thank you very much.
May I answer on that one?
Yeah, go ahead. It seems Minu is out of the loop, or has been for a short second. But Regina, just go on. Yeah,
with the that's an observation which can be made all around the world, that the low wage work and also especially the work on the field is done by the female or by women, and they take up the loads of the pesticides. And this is a problem of worker protection in the first place. And then in the second place is also, then there comes the gender problem into the vision, because it's mainly men that make the rules, and it's women that are affected by those rules. And if there was a better worker protection for everyone, then also the women working on the field could be protected better from the chemicals they are exposed to. And this is also, we've been talking about the gender pay gap, but there's also a gender data gap, which is because most of the chemicals, there is risk assessment been done on chemicals, but it's exposed to the humans. The tests are done in mice or rats, and then it's extrapolated to the human being, and the human being is a standard 70-kilo male, and men have a different amount of body fat, and they have a different metabolism. So what it does to a man is not the same which effect the chemical will have on a female body. So there we have also the aspect of the gender data gap, which needs to be closed.
And if I may add, this brings us again to this inter and transdisciplinary or even broader interaction you need. And I can tell from my own perspective in the Environment Agency, we are in the chemical safety unit. So it's a department, so it's the largest unit. It's several hundred people on chemical safety. And of course, our focus is at first on the substances. But if you change your perspective to the application areas, then you suddenly realize, oh, you have to talk with those who are applying it or who are doing the rules, how you have to apply it. And suddenly you realize people are affected differently, and the gender perspective is a very important one to realize that, and to have on the perspective for the application you look at, and to bring in all those who are concerned and affected and have their benefits and have their impacts to bear. And so you again need this interaction, which is already on the non-scientific level. You have to really bring that together, and that's what I learned over the years. I'm also a natural scientist, but as a SAICM focal point, it's also about interaction on many specific topics where you want to achieve something, and you realize it's not only one perspective but several, and you have to explore each other to get closer to a certain goal, what you have to agree for, at first.
Thank you very much. I'm also needing to look at the clock, but I'm also looking at the chat, and I'd like to just share one thing that's in the chat, and then maybe pose the other bit that's in the chat as a question to our speakers as a last question round. The one thing that I'd like to share is about the chemical leasing. So Dragana is sharing a link here as well, and she's alerting us that there's the Chemical Leasing Award from this year. It includes also female aspect and female-led initiatives that are invited to apply. And the application deadline is exactly in 2 weeks' time, on the 15th of December. You see the link here. So if you're interested and look at the chemical leasing and at the award, I invite you to use that link. That's in the chat here. We will also share it with the report of this meeting. And then I'd like to make the question from Alwyn Martin, the closing question to our speakers. She's talking about the question of science-based and values, and saying regulation to chemicals risk assessment, there can be little recognition from those involved in the field that defining protection goals or adverse effects require normative value judgments. It is often argued that decisions should be purely science-based, without recognition that science is not necessarily value-free. how do you think these preconceptions and barriers could be overcome, which I think is certainly an issue when you look at sustainable chemistry and gender. So let me, if I may, like to go around and see if Regina and then Hans Christian and then Klaus Kümmerer would like to comment. Regina, would you like to comment on this?
Can you just, I'm not sure if I got the question right. The statement was that decisions should be made purely science-based, but then on the other hand, science is not always just a neutral basis, right?
Well, I think she's arguing that it shouldn't just be science-based, but that normative value judgments need to come in, as was said by previous speakers as well. And when we think about gender equality, that's surely the case.
Yeah, of course, the normative values should also play a role in decision making, and the decision should not only be based on the scientific facts. The scientific facts can be the basis, and from then you need to check. As I said in my answer before with the gender data gap, is the scientific knowledge or the scientific data you have, does it show the full picture, or is it also just like just a small portion of what should be seen? And we need to have the broader perspective and then take into account who is all affected, and take a look around the table, for example, who's sitting there, and then questioning who is not sitting here and who is not in the room, and who might be also affected by the decisions we make, and then go back into the process and then reevaluate or even gather more data.
Thank you very much, Regina. Hans Christian, do you want to add anything?
Yeah, a bit perhaps. Of course, the decisions should be science-based, and I wonder if people say purely. But again, it's then it comes to the interaction. Of course, you have a science base for, let's say, a toxicological value, but you have to consider vulnerable groups well considered, and of course you assume exposure conditions for the scientific assessment. But maybe they are not realistic, and then you have to have interaction with those who apply it on the field, and it may be different at 10 degrees centigrade or at 40 degrees centigrade. We know that with personal protection equipment, that you can of course define it on a scientific basis that it is needed, but maybe that's not particularly wise if you look at the conditions where they are applied, and there you need to have more interaction, and I think that should be overcome again by adequate interaction and exchange of those who are concerned.
Thank you very much, Hans Christian. Klaus Kümmerer, is there a comment you would like to add?
Yeah, briefly, I do agree what has been said, and maybe from a different point of view, we have to aware that I would say if it's done good, science is not the methods, etc., should not depend on values. However, what we are interested in, where to get scientific data, asking questions, where to apply data, which questions to be answered. Yeah, that's important, and that determines what science sometimes is doing, especially nowadays where we have all this third-party money-driven research, and not for curiosity. And so I think we have to better understand, and I think the gender data gap is an example of this. There was no interest from the part of society, and also science in terms of a society and community has some drivers which are not science immanent, but they're part of political of science policy. Yeah. So where do you allocate money for? But all these are societal or individual decisions. Yeah. All this impact assessment of scientists that brings forward a lot of Me Too research, and so science is a tool, I would say. Yeah. And we first have to decide where do we want to apply it and for what reason, and what do we expect, which questions do we want to have answered. And in this context, yes, I do agree that it's science is it's not the gold standard. You say it's just a tool to get insight, but what we which insight we want to get and what to do with this insight. That's again based on our value propositions.
Mm-hmm. Thank you very much. I'd like to thank the three speakers and everybody who participated actively and was listening. We always promise you 45 minutes, and we find it harder and harder to keep to that. Thanks very much also on the comments on the science, the values, and I would maybe add the rights issues that all come in here when we look at sustainable chemistry as well as gender. And I'd like to hand it over to Anna to close it off and remind us of our next session.
Okay, so I just wanted to say thank you all very much for joining us today. If you have any further question or you are looking for more information, then please check our website or contact us individually, and join us next time for our last webinar this year. It's the webinar 6 on December 22nd, and there we want to discuss how gender could and should be implemented in the SAICM Beyond 2020 framework, together with Brenda Kukuk from the SAICM Secretariat and Julia Carlini from CEIL, the Center for International Environmental Law, and she's also a member of our informal Women and Gender Advocacy Group. So we are looking forward to seeing you there, and thank you all, and I wish you a very nice afternoon. Bye.
Thank you. Thanks, Anna. Thanks very much, everyone. Thank you.